Hey there, Mr. Wilford here, and I just wanted to take a look at Chapter 8, Section 2. We're taking a look here at trigonometric ratios, and this is actually a very important section, and you'll actually see this stuff plenty of times in your math career, and this is one that you really want to make sure that you take a look at, and there's some good application problems that go with this as well. And what we are going to look at here are some of the trig ratios. If you ever take any kind of trig class or anything like that, this is kind of the basis of all of that. And when we talk about a trig ratio, what we're talking about is a comparison. And we're looking at the sides of a right triangle. And this right here, the trigonometric ratios, the definition of sine, cosine, tangent. You've probably heard of that or maybe even seen that before. These are some very good things to maybe jot down as some notes as far as the right triangle goes. For sure you want to maybe kind of get at least one of these from each definition. So when you talk about sine of angle A, we're really looking at this angle right here, angle A, and the definition then is going to be the opposite leg, which is side A, divided by the hypotenuse, which is side C. You can see here that if you go to angle B, which is up here, it's still the opposite leg over the hypotenuse. So the definition really stays the same. You're just looking at two different angles and some different sides. Cosine of angle A is the adjacent leg, so that means we're talking about the side next to it, the leg of the triangle next to angle A divided by the hypotenuse. And then tangent A, if we go back to angle A here, is the opposite leg A divided by the adjacent leg B. And so again, the ratio part of this really is just a fraction. And people kind of get confused, or they're not sure exactly what's going on here. But you're really just comparing the three sides of the triangle by sine, cosine, and tangent. So when in this example here we're looking at sine r, so first you go to angle r here, and then sine, the definition is opposite over hypotenuse, so we're going to go opposite, which is 12, over 13, the hypotenuse. And if you simplify that fraction, if you just take 12 divided by 13, you get 0.92. And that would be the ratio that you would get there. Here's some other examples using this triangle here as well that you can look through. And again, you're just finding the ratios there. Here is a special right triangle with a 60-degree angle. And again, you can take a look at sine of 60, and because this is a 60-30, a 90-60-30 triangle, we have this kind of comparison. If this is side S, this is S times the square root of 3, and this is 2S. And so what happens here are the S's actually cancel out. Now the nice thing is your calculator actually will do a lot of the work for you for some of these problems. For example, if you have cosine of 76 degrees, you can punch that into your calculator, and that'll give you something like 2.24, and that would be the ratio of this angle. And you can see here that you can use your calculator for all of these as well. This leads us to some good application problems, or good problems that involve triangles, right triangles, and we can actually solve some of these right triangles, which means that we want to find the side. So if we're given angle A here is 41 degrees, and we're given side A, which is the opposite, 6.1, we can do the math here, and we can actually find the length that we're trying to find here. So we can find this hypotenuse here, or this side right down here, the other leg. And if we use tangent, it would be opposite over adjacent, and we can plug that into our calculator and solve for that side. So take a look at a couple of these examples here. They're pretty good. If you have any questions with this stuff, please be sure to let me know, and I'll help you out. And be sure you have a great calculator. All right, thank you very much.